All right, so advanced coordinate geometry starting on page 646. All right, so jumping into this advanced coordinate geometry chapter, Lee, could I have you read our goals review, please?
Sure. At the conclusion of this chapter, you will be able to accomplish the following. Apply skills of graphing in the xy plane to more unusual concepts. Identify which quadrants will contain parts of a graph in the xy plane. Identify the graphs of functions of different degrees in the xy plane. Know how to work with the equation of a circle in the xy plane, and understand how changes to an equation will change the graph in the xy plane.
So, as you notice, lots of stuff about the xy plane. Still dealing with this idea of coordinate geometry, graphing things in the xy plane, but building off of what we've done previously to see some more unusual ways the SAT can test essentially the same concepts that we've looked at previously. And so let's jump in and see some other ways this is going to happen. So not just looking at intersections and what have you, but also seeing things like distance. So Kristen, can I have you read question 12, please?
In the xy plane, the equations above intersect at points C and D. What is the distance between C and D?
So Kristen, what is the question asking for?
Distance between C and D.
Excellent. So we want the distance between C and D. And so Ken, how are we going to go about figuring out the distance between C and D?
Well, it says the equations intersect there, right?
Exactly. So what do we have to do with the equations?
We could set them equal to each other.
Awesome. And why is setting them equal to each other probably going to be the most effective way here?
Well, because they're not like asking for like the value of either point. They want like the distance between them.
Mm-hmm. And what do we see about the equations themselves that
They're
makes them
both equal to y.
Exactly. If they're both equal to y, as we've talked about previously when we're solving for intersections, see what the SAT is giving you to figure out the most effective way. If they're already equal to y, we just set them equal to each other. So Ken, talk me through that.
So you have the absolute value of x minus 2 is equal to 4.
Excellent.
And then if I remember, that needs to be two different equations. That needs to become two different equations.
Exactly. Absolute value, if you have the variable inside, we have to deal with both the positive and the negative version. So Ken, what are those two different equations going to be?
So you wind up getting x minus 2 equals 4.
And
the other one basically just becomes x minus 2 equals negative 4.
exactly. The positive and the negative version of the other side of the equation. And then
Oh, you just solve them.
Awesome.
So on the left one, you add 2 to both sides, and you get x equals 6.
excellent.
On the right side, you add 2 to both sides, and you get x equals negative 2.
All right. But as you were saying, we're not just looking for the points of intersection. What do we need to do with this?
The distance between them,
And so how do we going to figure out the distance between them?
it's the difference between the x's.
Why do we care? Why is it just the difference between the x's?
Because I'm pretty sure these would have the same y.
Because what do we know about y?
It's supposed to be equal to 4.
Exactly.
It's like a line.
Exactly. It's just going to be a line parallel to the x-axis, so there's no reason to consider y. It's only going to be x, and so how do we find the distance between that then?
You subtract them.
So
6 minus negative 2 is like 6 plus 2, which is 8.
excellent. And is that going to be an answer choice here?
Yeah, that's C.
So as we've been seeing across all these different subjects, reading the final question is super important. We didn't want just the points of intersection. We wanted to make sure we find the distance between those points of intersection. Additionally, combining some of our more unusual equations, here the absolute value equation, with some of our ideas of coordinate geometry, but it's still just combining different topics that we've already seen before. It's just the way the SAT is making things a little bit more convoluted. Right. All right, so we just saw how we had to use one of our less common equations, this absolute value equation, but still using what we knew to answer the question. Let's see another question where we can use our knowledge of how the equations work to help us answer the question. And so Lee, can I have you read the question for number 8, please?
What is the x-coordinate of point B?
So what are we looking for?
The x-coordinate of point B.
Absolutely. And so what are our bite-sized pieces that are going to help us find the x-coordinate of point B?
Well, we have a parabola that contains 2 points, one of which is point B, the other is point A.
Awesome. So what's the parabola they give us?
Y equals x minus 4 squared minus 3.
And so, and as you said, it contains A and B, right?
Yes, it contains A and B, and we know the x-coordinate of point A.
And what is the x-coordinate of point A?
It's 1.
And then, well, how does that help us find point B?
Well, we know some more
What else does it tell us about point B?
well, it tells us that point B is going to be, well, we know, the other thing that we know is that points A and B have the same y-coordinate.
Exactly. And so, let's think about how the vertex form works. Like, how does this vertex form work? What does the vertex form tell us?
Well, it tells us the point of the vertex on a parabola.
Exactly. Where is that point going to be?
It's going to be at the point 4, -3.
So 1, 2, 3, 4, 1, 2, 3. So it's going to be here, right?
Yeah.
And so how does that help us?
Well, we know the x-coordinate of point A, and we're looking for the x-coordinate of point B,
Mm-hmm.
and they have the same y.
Exactly. So x-coordinate of point A is 1, right?
Mm-hmm.
So that's going to be like over here.
Yeah.
Well, how does that help us? If we know this is over here, well then clearly B is going to be over here.
Mm.
But how does this help us?
Well, then the x-coordinate, the 4 of the vertex, should be the midpoint of our 2 points A and B, x, y's, or, just in general.
Exactly. The vertex is going to be the middle of the symmetrical parabola. So if this is at 1, comma, whatever, we don't care, this is at an x value of 1, well, how far is it to the midpoint?
3.
3. Which means how far should point B be from that midpoint?
3.
3. And so if it's 3 from the midpoint,
Well, we just add 3 to 4.
and what is 3 plus 4?
7.
And is that an answer choice?
Yeah.
Which answer do we get?
D.
And so here we can use the fact that the vertex form gives us the shape of the parabola, and we know some things about parabolas. And so we know, hey, we know it's symmetrical, and so we know it's going to be the same distance from the vertex line as the other point, and we can use that to find it without having to go through the equation and solving for y and then resolving for x. So sometimes they're going to ask about the coordinates of how a line lies in the xy plane. And so we have to remember how the coordinates are labeled in the xy plane. And so, Lee, if we have the xy plane, which coordinate is which? Like, which quadrant, excuse me, is which? Like, how do we number our quadrants in the xy plane?
Well, as we can see on page 648, you have quadrant 1 is in the top right corner. Quadrant 2 is then going counterclockwise in that direction, then 3, and then 4.
Excellent. And so, as you pointed out, sometimes on a question like this, the SAT will actually just give you so you don't forget which way it is, but sometimes they may not.
Mm-hmm.
And so let's see how this concept of what the quadrants are relates to how the SAT might test this concept. So Anne, can I have you read number 9, please?
Sure. Line M has a positive y-intercept and a negative slope in the xy plane. Which of the following must be true?
So what's the question asking for?
Which of the answer choices is true or must be true?
Exactly. And so certainly anything could be true, right? So let's look at our answers. What are our answer choices describing?
The different quadrants.
Exactly. So what bite-sized pieces should we work to figure out the different quadrants?
The first sentence they gave us about they said M had a positive y-intercept and a negative slope.
Absolutely. So it has a positive y-intercept and a negative slope. And so what is that going to mean about our line?
It's going to go like down.
It's going to go down, and where is it going to start?
Above the x-axis.
So we can literally draw it in, right?
Sure,
They
yeah.
were kind enough to give us the diagram. Let's use it.
Yeah.
So something like this, and then he said it's going down, right? Because that would be a negative slope.
Uh-huh.
And so what is that telling us about the quadrants?
Wait. Which quadrants the line touches? Or?
Exactly.
Okay.
Because you said the answer choices are about quadrants, so which
Oh, okay.
quadrants does it touch?
1, 2, and 4.
Absolutely. So let's go to our answers and look for an answer that is consistent with that. And answer choice A.
Only part, because it says 1 and 2.
So we
So-
can eliminate that. Answer choice B.
The line passes through quadrants 1, 2, and 4 only, which is what we have. And
Absolutely. C.
Then, 2 and 3 only. It doesn't go through 3.
Doesn't go through 3.
And
Answer
then-
choice D.
The line passes through quadrants 1, 3, and 4 only, but it doesn't go through 3.
Excellent. And so questions about quadrants might just ask, where does this line fall in the xy plane? And so if they give you a graph, obviously let's use it, draw our line in there. And if they don't, draw it out yourself. Draw the xy plane, put in the information that they told you, and visualize where it's going to be. This sense of visualization is going to be particularly important if the question's asking about a system of inequalities in the xy plane. Question, Ann. Yeah.
About that, how do you know it won't ever go in 3?
Excellent question. So let's think about the pieces that they told us, right? So the positive y-intercept. Well, we can try to move this line, right?
Right,
Well,
yeah.
if we want to try to get it to 3, we put the y-intercept kind of here-ish. Where would we put the line if we were trying to get it to 3?
Well, I was just thinking that maybe if it was steeper or, I don't know, I just couldn't think of another way. I was just
Okay.
wondering if there was another way we could draw it.
Well, let's make it steeper.
Okay.
Let's make it steeper. Let's make it even closer to the origin.
Uh-huh.
If we make it steeper and yet closer to the origin, can I get it to do 3?
No, it still doesn't go through that.
It still doesn't go through that. So if you're not sure, absolutely draw a couple of lines, right? They didn't give us a lot of specific information. In fact, the information given us is incredibly general. Positive y-intercept, so it's anywhere between like 0.01 to like infinity. And then negative slope to like, could be super shallow, could be super steep. No matter what you do, because we're starting at a y value of greater than 1, and if it's a negative slope, what's going to happen as we move to the left?
It's gonna, it'll be,
It'll
go
still keep going up, right?
Oh, yeah.
The values
yeah.
would keep going up.
Uh-huh.
And so if we're starting, if that's 0 something positive, and we move to the left, we're still going to get higher. There's no way we can get down here.
Okay.
So once again, the easiest thing to do is just draw the lines.
Sure. Okay.
Follow what they tell you. You're not sure, draw a couple lines. Here, you could spend all day, but
Right.
you'll figure out pretty quickly that, oh, this is the only thing that's happening. And alternatively, the other thing is, even after your first line, you go through the answer choices. What's the only answer that's true based at least on your first line?
B.
B,
Yeah.
right? So answer choice B would still be what we would go with because
Yeah.
it's the only answer that's true based on what we see just even
Okay.
with our first line.
Okay.
Excellent question. So let us see how this works with inequalities XY plane. Ken, can I have you read 26, please?
Sure. If the system of inequalities y is less than or equal to negative 3x plus 2, and y is less than negative 1/3 x plus 2 is graphed in the xy plane, which quadrant contains the solutions to the system?
All right, so Ken, what's the question asking here?
Which quadrants contain the solution to the system?
All right. So we've seen questions before that ask about solutions, right? And typically when we're talking about solutions to a system, what are we talking about?
We're talking about like where the two lines cross.
Exactly. But those are when they're just lines, right? And are these equations?
No, they're inequalities.
They're inequalities. And so do you think we care about where that point of intersection is?
I mean, well, sort of. It's more like wherever they cross over.
Exactly. We need to figure out where these different inequalities cross over. And so, well, what bite-sized pieces do we need to figure that out?
Well, we need the two lines.
So what are they?
Y is less than or equal to negative 3x plus 2.
And
and y is less than negative 1/3 x plus 2.
All right. And so how are we going to go about this? What do you think we should do with
We
these?
could try sketching them.
Absolutely. In particular, if they're asking about quadrants, it's going to be way easier to visualize where it is rather than trying to like mentally do it or try to do some math and figure out something. So let's sketch the XY plane. And then, Ken, we have our XY plane. What next?
We can try sketching the first line.
Absolutely. Because what form is it in?
It's the y equals mx plus b.
Right? It's our nice form. It's the form that tells us stuff. So how should we go about sketching this line?
So you can start with the plus 2. So 0, 2 is where it should cross the y-axis.
Absolutely.
And then for every 3 it goes down, it goes to the right one.
Excellent. It's a -3 slope. So it's going to be pretty darn steep, right?
Yeah.
Excellent. So we can even label this. But what are we going to do with this pesky little less than or equal to?
Well, I think the equal to part means the line should be solid.
Awesome.
And then the less than, you go like below. The
Absolutely.
region below the line.
And the best way to do it is to actually just go to that y-intercept again and say, okay, if 0, 2, well, if we just make x equals 0,
Right.
we just have y is less than or equal to 2. Well, where is y less than or equal to 2 at this point?
Below that.
Below that
the
line. So we know that all of these points are going to be included in this inequality.
Right.
And so, Ken, what about the other inequality?
So it's also crossing at 0, 2.
Mm-hmm.
But this time, for every 1 it goes down, it goes 3 over.
Excellent. So going to be a bit less steep here. And then what?
Well, so this is different because it's not an equals symbol.
Exactly. So do you remember how we represent that in our graph?
I think you make the line dotted.
Exactly. So we're going to make the line dotted to represent, hey, this is going to be, does not include points on that line.
But you'd still shade below it.
Exactly. Once again, if you go to this point, y is less than 2, so we want everything below that. And so I will shade those in this direction. And so then if we're talking about the solutions to the system, Ken, what part are we concerned with?
Like where the regions overlap.
Exactly.
I feel like they overlap everywhere.
Yeah, right? This, well, clearly quadrant 3 is
Definitely
totally
3.
And then this is definitely part of quadrant 2. We got this little chunk. It's not a huge chunk.
But it's still part of quadrant 1.
And then we got all this stuff down here for
quadrant 4.
Exactly. So are we ready to go to our answers?
Yeah.
Well, because what are we looking for?
An answer that has all 4 quadrants in it.
Which is
A.
A. So when you're asked about questions about quadrants, sketch the lines. It's much easier to visualize how these quadrants work. If they give you a sketch, awesome, you can just draw right on it. And if they don't, still do the sketch. It's actually going to be easier to sketch it and visualize it than to try to solve it mathematically and consider where do I have positive x's and negative y's and all that stuff. Just draw it out. So beyond just lines in the xy plane, we also have to consider curves in the xy plane. And so when it comes to curves in the xy plane, it's helpful to know a little bit about how some of the other curves besides parabolas look. So a third degree parabola, well, first of all, Lee, what do we mean by a third degree, or not a parabola, but a third degree equation?
Well, the first, the highest power that it goes to is the third power.
Exactly. And so if you have something with the highest power to the third, you're going to get a graph that looks something like this. And it could be like this, or it can go in the other direction. But at one place, they're going to go down to negative infinity. The other place, they're going to go to positive infinity. And then we also sometimes see fourth degree equations. And Anne, what do we mean by fourth degree equations?
The highest exponent is a 4.
Excellent. And so as you can see there, we have a parabola, or we have something that kind of looks like a parabola but has like an extra little loop in it. And so also notice here that these two graphs have a certain number of real roots. So this third degree parabola, it says it has one real root. Lee, why do we say it has one real root?
For the fourth.
For the third degree.
Because
What do we mean by roots?
well, it would be like a 0
Exactly, and how many zeros do we have?
or 1.
Exactly.
Okay.
So we have one real root. And the reason why we say real is that if we solve that equation they gave us, we would get an imaginary solution as well. We'd have to take the square root of a negative number. And then this one has 3 distinct real roots, because it hits it 3 times. But then it also has this thing we call a double root. And if we see that it touches the x-axis and comes away, we know that that root is squared. So here we would need an x squared as some part of our equation once we factored it. So the key with all of these is that it's going to help us with process elimination in questions like question 13. Ken, can I have you read question 13, please?
Which of the following could be the equation of the graph above?
And so what's the question asking for?
What's the equation of the graph?
And so they gave us this graph. And so how can we figure out what the equation of the graph is going to be?
Well, I mean, only because we just talked about it, but it looks like the picture of the fourth degree equation we had.
Exactly. And so if we know it has to be a fourth degree equation, what could we do with our answers?
Just go to POE.
Absolutely. If we recognize it's fourth degree, we can do some POE. And so what can we eliminate?
A, B, and C.
Awesome. And what are we left with?
I guess D.
Excellent. So if you remember what these different equations look like, hey, look, we can just knock it off the D. And then Lee, if we didn't remember, what could we do to try to solve this?
Well, we could start plugging in the points that we have.
Absolutely. If you forget this, you can plug in the points you have. And we have a calculator here. So Anne, if we were really stuck, but we really wanted to do this question.
I was just going to graph the answer choices.
Exactly. Another possibility if you have a graphing calculator is graph the answer choices. But if you remember what these equations look like, you can sometimes get what should be a fairly challenging question can actually be a little bit of a freebie. Hey, I know what that's supposed to look like. Knock off answers that can't look like that. And in this case, you're left with 1. So beyond just curves, our functions in the xy plane, we're also going to see circles in the xy plane. And so the equations for a circle is a little bit funny. Kristen, could I have you read that box at the top of page 651, please?
The standard form of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. If the circle is centered at the origin, the equation is x squared plus y squared equals r squared.
All right. So notice here that we have another equation that kind of looks a little bit funky, right? Now we have x and y on the same side of the equation, and we have a bunch of squareds going on. So there's 2 big things when it comes to remembering this equation that are going to be traps that you want to be looking for when you're working questions. First of all, the equation has subtraction here. And so remember, you need to flip your signs when you're finding your center. The other piece is that the radius is squared in the standard form. So once you're in the standard form, you need to do the square roots in order to get to your actual radius. One last point. Lee, what does this equation kind of resemble to you?
Well, it kind of looks like the equation for a parabola.
Yeah, a little bit for a parabola. And also, when do we have something squared plus something squared equals something else squared?
Well, we have the Pythagorean theorem.
Exactly. And so if you remember the Pythagorean theorem, it can help you remember that the general form looks like this. We still have to memorize the pieces, but it can be a helpful mnemonic to remember at least generally how this works. So let's check out a question that is going to test our knowledge of this sort of equation. Kristen, can I have you read number 7, please?
In the coordinate plane, if the point 1, 3 is on circle M and circle M has a radius of 4, which of the following equations could describe circle M?
So Kristen, what is the question asking for?
Which equation could describe circle M?
Excellent. And so if we were looking for the equation that describes circle M, what sort of pieces should we look for? Well, what's one thing it told us about this circle?
It has a radius of 4.
Awesome. And so if it has a radius of 4,
So can we look at the answers and know that, so the equation would be r squared, right? So do we know it has to be a or b?
absolutely. Keeping in mind this is going to be r squared, not just plain old r. If the radius is 4, as you're saying, it has to be 16 on that side because it needs to be squared. And so it has to be a or b because c and d have the wrong radius. Excellent. So absolutely, just as with everything else we've been doing, but with circle questions, once you figure out a bite-sized piece, check out those answers. You can knock off a couple answers. And then, Kristen, what else did it tell us about this circle?
We have x, y points. on the
Exactly.
circle.
What point do we have?
1 and 3.
So we have points 1, 3 is on the circle. And as you're saying, that is x, y, right?
Mm-hmm.
That's the same thing as telling us that x equals 1 and y equals 3. How would that help us answer this question?
I guess, could we plug them in?
Exactly. Just like every other equation we've dealt with, no matter how weird it looks like, x, y just represents any point on the figure. So if at 1, 3 is on the circle, when x is 1 and y is 3, it should work. So which answer choice do you want to test?
I guess the first one.
May as well, right? And so the first one, what is it? What do they give us?
X minus 2 squared plus y plus 3 squared equals 16.
And so what happens when we plug in those points?
Okay, so we have 1 minus 2 squared plus 3 squared equals 16.
Excellent.
So we have negative 1 squared plus 36.
Yeah, this is going to be 6 squared, right?
Uh-huh.
16, but you're already saying, well, that's going to be 36 on its own.
Yeah.
And we're going to add more stuff to it.
Yes, that's not going to be right.
So what has to be our answer?
B.
Absolutely. So once again, remember the parts of the formula, watching out for these tricks. You can see that C and D, they were trying to get you to forget that radius squared should be radius squared and not radius. Eliminate answers that don't fit what you know. And if they give you a point on the circle, just like every other equation, throw that point directly into the equations and eliminate answers that don't work for that particular point. So sometimes when we're dealt with a circle, the answer choices or the question itself might not be in standard form. It might be in kind of an obnoxious foiled form. So Lee, can I have you read that box on the top of page 652?
To convert a circle equation into the standard form, complete the square.
All right, completing the square.
Would you like me to keep
Yeah.
So move any constants over to the right side of the equation.
So you move the constants to the right.
Then, if there is a coefficient on the square terms, factor it out of both sides of the equation.
So factor out the coefficient on the square terms.
Next,
Yep.
take half of the coefficient on the x term, not the x squared term, square it, and add it to both sides of the equation.
So a little complicated, but have you seen something like this in math class before?
Yeah, absolutely.
Yeah. So have you done it with a circle?
No,
But this seems familiar, right?
it seems like something we've done before.
Absolutely. Half the coefficients on x term, square Add both sides.
Then next we're going to convert the x squared term, the x term, and the constant on the left to square form. And so that'll look like x minus h squared.
Excellent. So this is why I call it completing the square. This operation gives us the number we need to make it a perfect square. So then we can just make it into a perfect square, which is what our equation looks like. And then our last step
Is to just repeat steps 2 and 3, but for the y squared term, or for the y terms rather.
repeat for y's. Awesome. So this sort of question where we have to do this operation is relatively rare on the SAT. So, but when it does show up, we're going to see that knowing how to do this is going to be essential to mastering these questions. And so, Lee, can I have you read question number 20, please?
Yeah, which of the following represents the center and the radius, respectively, of the circle described by the equation x squared plus y squared minus 8x plus 6y equals negative 21 graphed in the coordinate plane?
So, Lee, what is the question asking for?
It wants us to find the center and the radius of this circle that they gave us.
All right. And what was the circle that they gave us?
X squared plus y squared minus 8x plus 6y
Plus y squared minus 8x plus 6y.
equals negative 21.
And so, is this in our form that just lets us be able to find the center and the y and the radius directly?
No, but it's rearranged and we could get it into that form.
Exactly. We got to go to completing the square. And so, talk me through it. What should our first step be?
Well, we have the constant on the right already.
So we don't have to do that.
Yeah. We should rearrange the x's and the y's so that they're next to each other so that we can see them.
Absolutely. So what would that look like?
X squared minus 8x plus y squared plus 6y.
And then nothing's happened over here, right?
That all still equals negative 21. Next, we're going to take half of that coefficient. So first we can start with the x. The negative 8, so half of that is going to be negative 4, and then we square it.
And what do we get when we square it?
16, which means we're adding 16 both to the left and the right.
Awesome.
And then if we, and so that will look like x minus 4 squared.
Excellent. And how do you know it's x minus 4 squared?
Because that's why we took the half.
Yeah. When we do that half, that will be what it ends up looking like. All of this, including the plus 16, is going to be our x minus 4 squared. And so, hey, is this part, could this give us part of what we were looking for?
Yeah, this gives us our x minus h squared.
Exactly.
Standard
So
form.
what should our h be?
4.
And so, can we go to our answers and at least knock off some?
Yeah.
Awesome.
Yeah, we could eliminate a and b.
Excellent. And so, as always, once you figure out part, use that to eliminate some answers because, hey, Lee, if time's going to be out in 5 seconds, what should you do?
You should just eliminate as many answers as possible and hopefully give yourself in this case, right, if we were running out, we'd give ourselves a 50-50 shot.
Exactly. So always when we figure out something, let's do that. And so, Anne, let's rinse and repeat with the y values.
Okay. So we're gonna take half of 6, so that's 3. And square that, so that's 9. And then add that to both sides.
Mm-hmm.
And then that's gonna be y plus 3 squared.
Exactly. Once again, this, what we got when we halved it ends up being there. So what does that mean about our equation? Or about our circle?
Oh, that the center is 4, 3. Or negative 3, sorry. 4,
Don't forget to switch the sign.
Yeah.
So we know the center's 4, 3. Does it help us eliminate it down?
No.
Unfortunately. So what do we got to figure out?
The radius.
And so how are we going to do that?
So add 16 and 9 with the negative 21.
And what are we going to get?
Positive 4. So r squared is 4, so r is 2.
Excellent. Always remembering to square root it to find the actual radius. And so what's our answer going to be?
C.
Excellent.
They tried to get us with D.
Yes. And this is the thing about this equation. Where did the wrong answers come from? How could you pick answer choice A, for instance? It has the right radius, But what did you forget to do if you picked A, Lee?
Well, you probably didn't do the switch to negative. You thought of it as positive h instead of negative h as far as the standard form
Or
of the
you
equation.
just
Exactly.
You just pulled it straight from there.
Exactly. Always remembering the two tricks to this equation, but then also remembering this completing the square method in case you need to get it into this form, because from this form you can't easily see the pieces of information we need. Okay, so we just saw how we needed to complete the square in order to get a circle into the standard form. Sometimes instead of asking us about the center or the radius, they're going to ask us about other points and how they relate to the circle. So Anne, can I have you read question 27, please?
Sure. Circle C lies in the xy plane and has the equation above. Which of the following points lies outside the circumference of circle C?
And so Anne, what's the question asking for?
We want a point that lies outside the circumference of the circle.
All right. And so if we're looking for a point outside the circle, Anne, how might we be able to go about doing that? Well, first of all, what bite-sized piece do we need?
I guess the circle equation.
And so what did they give us?
They said x minus 2 squared plus y minus 5 squared equals 36.
Cool. And so they gave us, this time in standard form, but are we being asked about the radius or the center?
No.
We're being asked about what?
The circumference of the circle?
And well, what about the circumference?
Something that's outside of it.
Exactly. And previously, what have we done when we have questions about points and equations?
We plug the points in.
Exactly. So can we just plug the points in?
Okay.
Cool, right? Plug in the answers, because what do our answer choices here represent?
Something that could be outside the circle.
Yeah, points, right?
Right.
These are our x, y's, and we're looking for the one, as you said, that's outside the circle. Now with plugging in the answers, after we've labeled the answer choices, Anne, what should we be doing?
Pick one to try.
Exactly. Now, are these in any particular order?
No. So
Yeah,
yeah, just I guess start with the first one.
absolutely. So talk me through starting with the first one. What should we do?
So I guess 7 goes in for x, so you have 7 minus 2 squared and 1 minus 5 squared and equals 36. So that would be 5 squared plus negative 4 squared equals 36, and then 25 plus 16, and that is 41, which doesn't equal 36.
Huh. So, if it doesn't equal 36, what does it definitely mean about this point?
It's not on the circle?
Exactly, but are we being asked for what's on the circle?
No, we want what's outside the circle.
All right, so here we can go back to this idea of how does this equation work? We know that if this chunk equaled 36, we would be on the circle.
Mm-hmm.
Well, what happens if this chunk is greater than 36? What do you think that means?
Would that be bigger than the circle?
Exactly. If we think about previously, we mentioned, hey, this is just really kind of a funky form of the Pythagorean theorem. This chunk is bigger than what it's supposed to be, which means it's further away.
Okay.
So what does that mean about answer choice A?
Is it our answer?
Absolutely. And so with our remaining answers, what do you think is going to happen with them?
They'll be on the circle,
Or
in the circle, I guess.
or in the circle. So they were going to be less than 36. And so here we can still be using plugging points into the equation, but we also have to add that extra layer of how does this equation work? If it was equal to 36, we know that would be on the side on the circle. But if it's greater than, we know we're outside. If it happened to be less than, we know we're inside the circle. And so use that plugging in, but also use your knowledge of the equation to see what's going to be outside the circle or inside the circle.
Okay.
So let's take this idea of graphs and now start talking about transforming graphs. So on the next page, now a lot of these questions can be answered using a lot of our other strategies. You can often plug in points. You can sketch it if you have your calculator. But remembering the transformation rules can often make these questions a lot more efficient. So Lee, can I have you read 32, please?
Yeah. What is the value of C?
All right. So we're looking for the value of C. So what bite-sized piece here is going to help us find the value of C?
Well, we're given a parabola.
Excellent. And what's the parabola they give us?
They give us y equals x minus 1 squared minus 6. And then we're told that parabola is then translated 9 units to the left, resulting in a new one. And that new parabola has the equation y equals x plus c squared minus 6.
All right. So if these are the bite-sized pieces that are going to lead us to C, how do you think we should start this one?
Well, we should probably try to draw the original parabola.
Absolutely. It's going to help us see. And in fact, what form is the original parabola in?
Vertex form,
So does that make it easier to draw?
definitely.
Absolutely. Because what are we going to be able to draw?
Well, we know the vertex. We could get the vertex from this formula.
Exactly. Because what's the vertex going to be based on this formula?
It's going to be 1, -6.
Once again, we have to flip the sign inside, but not outside. So 1, -6. And then what's going to be true about the vertex, or about this?
It's going to be an upward facing,
And how do we know it's upward?
because we know because of the it's going. We have it a positive
Exactly.
parabola. If it was negative, then it would be going down.
Yeah. And then what did it say is going to happen to this?
It's going to be translated 9 units to the left.
So if we're going 9 units to the left,
Well, then we just move the vertex 9 units to the left.
and so if we move the vertex 9 units to the left, where does it end up?
It ends up at the point -8, -6,
Absolutely.
which would then give it a new formula.
Absolutely. And well, how are we going to figure out that new formula?
Well, we can just, if we're following these same rules of the parabola, right, it would be an x plus 8 inside the square term.
Absolutely. Once again, just using what we know about vertex form, saying, oh, it's now going to be an x plus 8. Once again, we have to flip the sign of our x coordinate in vertex form, -6.
But other than that, all the features stay the same.
Exactly. Well, does that answer the question for us?
Well, it does, because it's just asking x plus c, so c must be 8.
Excellent. And so we can absolutely draw these and use our drawing and then use our knowledge of the forms to help us answer this question. But remembering how transformations of graphs works can often help us do this more efficiently. And so, Kristen, can I have you read that box, please?
In relation to f of x plus k is shifted upward k units in the xy plane. F of x minus k is shifted downward k units in the xy plane. F of x plus k is shifted to the left k units in the xy plane. F of x minus k is shifted to the right k units in the xy plane. Negative f of x is flipped upside down over the x-axis. F of negative x is flipped left to right over the y-axis.
Excellent. And so here, Lee, how might this have helped us answer this question even more efficiently?
Well, if we know that, I guess the third one of those, it tells us what would have been happening to this in this question.
Exactly. We still need to know how vertex form works to realize we're adding to the inside of the parentheses. But we know, oh, we need to add 9. 9 plus -1.
Yeah, then we know it was 8.
Exactly. And so remembering these rules will often help us to be more efficient, but also being able to sketch them can be helpful. And sometimes they're essentially telling you to use these rules to determine what's going on with the question. So Anne, could I have you read number 15, please?
The function h is defined by the equation above, which of the following is the graph of y equals negative h of x in the xy plane?
So what's the question asking?
What is, we're just choosing the graph that is the graph of y equals negative h of x.
All right. And so what bite-sized piece might we need here?
I guess the equation h of x.
So they gave us the equation of h of x, and what is h of x?
3 minus 3 to the x power.
Okay. And so, cool. So if that's the equation they gave us, well, if this were a calculator section, what would you probably do?
You could just graph it, I guess.
You can just graph it, right? But we don't get a calculator, right?
Mm-hmm.
So what do you think we should do instead?
Could we plug in?
Yeah, absolutely. We can plug in because plugging in would tell us what sort of things.
Like some points on the graph.
Exactly. So talk me through. What could we plug in?
Well, it's the x point, maybe like 2.
Okay. So 2 for which?
For x,
So 2 for x. And if x equals 2, what are we going to get?
we'll get 3 minus 9 is negative 6.
So then we got a y equals negative 6. Could we do another point?
Oh,
Or maybe another
like
couple?
1. Can we? Is that okay? 1.
One's okay.
Okay. So then we'll have 3 minus 3 to the first power, which is 0.
Cool. So we know we also have x1, y0.
And
There's another number that probably is really nice to use. 0.
oh, okay.
Because if we use 0, it's still going to give us a point, right? And it's actually going to give us a point that's easy to spot on the graph.
Okay.
So if x is 0, what are we going to get?
3 minus 3 to the 0, so that's just 3 minus 1.
Yes.
So 2.
All right. So now we have a few points, right? So let's sketch what we have. So based on what we have, what's this going to look like?
So we'll have 2 commas, what is it, negative 6. And then 1 comma 0. And then 0 comma 2.
All right. Well, this is looking kind of funky, right? All right. But what's the question asking for?
Not that. They want the negative h of x.
And what does the negative h of x mean? What do our transformation rules tell us?
That we should, it's flipped upside down over the x-axis.
Exactly. So if we're flipping it upside down over the x-axis, based on just these little pieces, well, let's flip it a point at a time. Where would we be flipping this to?
So if that's positive 2, it'll be negative 2 now.
Exactly. What about this point?
Does it just stay the same?
Exactly. If you're on the x-axis, you don't move.
Okay.
And then this point,
So that would be 2 positive 6.
so we know we need this chunk as part of our answer, right?
Mm-hmm.
And so let's go to our answer choices and see if we can at least eliminate some things that don't have those pieces. So what about answer choice A?
I would,
Does it seem to have, like, once
Yeah.
again, we want this one.
okay. Yeah, I would keep that one.
Because it seems to have negative 2 and then 0 and then that.
Okay.
What about answer choice B?
I think, no.
No. Wrong y-intercept at the very least, right?
Right, yeah, yeah.
Answer choice C?
Definitely not C, because it doesn't go in the first quadrant.
Absolutely.
And then, D, no, because we need the 0, negative 2, which we don't have in D.
Awesome. So what are we left with?
A.
A. And so, especially if it's a weird equation that, if you don't remember what happens when you have an exponential equation that's negative and then you have a constant and my head hurts, well, we can plug in a couple of points, get a sketch going, and then apply the transformation to the sketch. And so that is going to help us figure out what we need our answers to do. And of course, using process elimination once we have enough to be able to start eliminating answers. All right.